One of the most common methods to transmit power is with an industrial pin and bushing chain. To achieve the lowest cost of ownership, the chains need to be periodically lubricated. The required properties of an effective lubricant include the ability to penetrate, high load-bearing properties, a low coefficient of friction, and the ability to disperse dirt, dust, and fibers. We'd now like to demonstrate these characteristics. To effectively lubricate a chain, the lubricant must be engineered to penetrate into the tight tolerance of the pin and the bushing. To demonstrate penetrating ability, we have a sample of 601 chain drive pin and bushing lubricant with a blue dye added. We'll put a small amount on the metal plate, insert the bushing into the lubricant, then insert the pin into the bushing. In order to wet the pin, the lubricant must creep vertically up the pin. We'll now remove the pin and check how far the lubricant is penetrated. And with the aid of the blue dye, you can see it penetrated virtually the entire length that was inserted in the bushing. The Falex pin and V-block test is a comparative laboratory measurement of a lubricant's ability to maintain a film between two metal surfaces under increasing pressure. During the test, the pin is rotating and the V-blocks on either side are then squeezed against the pin with increasing pressure until seizure of the pin. The gear mechanism applies an increasing load until pin seizure. Typical of a light bearing oil, seizure occurred after 1 minute and 35 seconds with a coefficient of friction of 0.14 and a very low load of only 400 pounds. This illustrates a typical test results for 601 chain drive pin and bushing lubricant. Maximum load 1,800 pounds, more than 4 times your typical bearing oil. The result is 2 to 4 times longer chain life, even under load. Coefficient of friction, 0.06. The benefit is measurable reduction in electricity needed to power the chain. Most industrial chains must operate in environments with dirt, dust, fibers in the air. It's imperative that any chain lubricant have the ability to disperse and suspend any of these materials in order to avoid buildup on the outside, but also the inside of the chain. To demonstrate a lubricant's ability to disperse and suspend dirt, dust, we'll put a very small amount of red iron oxide first into a lightweight petroleum oil, then into a formulated chain lubricant. Now, with some gentle agitation to move it around, what you'll begin to see quickly is on the right-hand side, the formulated chain lubricant begins to quickly disperse and suspend the pigments. Continuing with the mild mechanical action, we'll now see the result. As you look on the right, you can see a formulated chain lubricant has almost completely dispersed the pigment and suspends it in the film. The result, the chain is clean on the inside as well as the outside.